I record on this computer. Okay. Greetings, Algebra Express. You made it to your first lecture. Hopefully you've printed out these lecture notes, and you should be working through the notes along with the video. Hopefully you'll pause the video before I work it out and try to work these things out yourself. And I want to start out by saying I didn't write these notes, so I may agree with the notes, I may disagree with the notes a little bit, but in general, they are good notes. Most of the stuff in there is really good. They're pretty well structured, and so I'm not going to complain about them too much, but I am going to say I find this title that they have a little odd. So this is from Marecek, Chapter 1. The title that they give it is Use a General Strategy to Solve Linear Equations. I got a little problem with this because we don't actually solve anything within these notes. We do a lot of order of operations, we do some evaluating, and we do some simplifying, but nothing we do is actually solving. And we'll talk more later in later chapters about what solving is, and we'll get a good definition of what solving is later. But we don't actually do it in these notes. And so with that said, the first thing that we're going to look at is the order of operations. And so math, you can kind of think of it as its own sort of language, right? And we have the certain words we use, and this is sort of like the syntax of the language. Like, how do we organize this thing? What sort of operations do we do first, right? How do we prioritize operations? And so with that said, I talked about pausing the video and doing things on your own. So like the best way to learn a language is to practice it. So the best way to get better at PEMDAS in order of operations is to do these things on your own. You're going to have to pick up your pencil and start writing some things. So we start with parentheses. The next thing we do is exponents. We do multiplication and division at the same time, and we do addition and subtraction at the same time. And we read things left to right, just as we read things in English, and in most languages, I think, read things left to right. There's a few that don't. But we should be used to reading things left to right, hopefully. I think the main thing where people mess up with PEMDAS is they try to do multiplication before they do division. So we're doing these things at the same time, left to right. They have the same priority, and so do addition and subtraction. And hopefully those things match a little bit in your brain, because those things are things that we call inverse operations. If we multiply by 2 and divide by 2, it's not going to do anything to the original number, right? And so you might ask, why do we do things in this way? And the best sort of answer I can give to that is someone decided a while ago this was the way to do them. So it's sort of like the organization of a language. There are different ways you can organize things, or you can organize language in different ways, and it's an equally valid language. So there are other ways that you can do these order of operations. And if you have a calculator, you might want to check on how your calculator is doing order of operations, because not all calculators are made the same. Not all of them do the order of operations the same way. And so I want to, before we even get to the problem on the paper, I want to do something a little simpler, just to kind of like highlight this fact right here. So I'm going to start doing it the right way. I'm going to do 6 divided by 2 and multiply that by 5. So if I'm doing multiplication and division at the same time, I'm going left to right. So the first thing I see on the left is 16 divided by 2 is going to give me 8. I'm going to multiply that by 5, and that's going to give me 40. So that's if we do it the right way. So the common mistake that people make is, I kind of said it, they'll do the multiplication before they do the division. And if we do that, hopefully you can see we're going to end up with the 2 times 5 first is going to give us 10. We're going to do 16 divided by 10. That gives me like what, 1.6, or you can write it as 8/5. And I know it's like the first lecture, but I hope you still realize 1.6 is not going to be 40 ever. So these are going to give you two different answers depending on how you do your order of operations. And so this is a really common mistake. Do not do this, right? And so after I did the wrong thing, I'm going to ask kind of a weird question. What if I want to make this correctly? What if I want to do this 2 times 5 first? There's a little correction I can make, and this is going to come into place if you like plug these things into a calculator or something like that. You might have to throw in a pair of parentheses, because parentheses have top priority in our system, right? It's the P in PEMDAS. It's the first thing we do. So if we want to indicate that we're doing this first, we can always throw parentheses around things. Mathematicians really like parentheses. Sometimes they like them a little too much and things get really confusing, but we'll cross that bridge when we get there. Okay. And so it's called PEMDAS, and just to like go at it a third time, I think we're grouping those two and we're grouping those two together when we do them. And so I guess they could have called it PEMA or something like that, but then I guess it would have been more confusing. I'm not really sure. So let's do this first problem. This one's a bit more complicated. And when you see something like this, the first thing I'm hoping is you look at this division sort of sign happening here. There's a numerator and a denominator. And so what we want to do is we want to calculate the numerator, and then we want to calculate the denominator. And then the last thing that we're going to end up doing is doing this sort of division that's happening here with this division bar. And so that division should really be the last thing. If I wanted to write it all out, I guess I could write like some bigger brackets. I could do something crazy like this and expand it. Dividing by is that all? Making it okay. I probably would not personally write it out like that, but that might be the sort of way you want to picture it in your head. You're going to do everything in here first, and then you're going to do everything in here, and then the last thing you're going to do is actually the division. So I'm not going to write it out like that anymore. But if we want to look at this, we're looking for things in parentheses first. So we're looking along here, we're looking along here. These are the things in parentheses. So I have to do these parentheses before I do the square up here. Parentheses, exponents. And so I'm doing the thing in the parentheses. And so within the parentheses, I have multiplication and I have subtraction. So I'm reading it left to right. I want to do the multiplication and division before I do the addition and subtraction. So if I'm looking here, I'm doing the multiplication first. And so I'm multiplying 6 by 3 should give me 18. 4 by 2 should give me 8. And I still have everything else. In the denominator, I can do a little bit here. So if I do parentheses, there's no parentheses here. The next thing I look for is exponents. So 4 squared is going to give me 16. I'm going to add that to 3 squared is going to give me 9. And now I'm looking, so I'm going back to the numerator. What can I do in this numerator? I'm looking here, the first thing I'm doing is parentheses. So the thing that's in the parentheses is 18 minus 8. So I have to do 18 minus 8, which will give me 10. And then I have to square that. This I can add together will give me 25. So I believe what I'm ending up with is something like 100 over 25. 10 squared gives me 100. And if I think about this, there are 4 quarters in a dollar. It's probably the way you're going to think about that in your head. Okay. So that one is pretty involved with the order of operations. The next thing is a lot more sort of a conceptual sort of thing. And what does this mean notation wise? So a lot of this stuff you might be asking yourself why, and the best answer I can sort of give you is some old guy who did it a really long time ago and would just kind of carried over into habit, right? We needed some kind of structure for the language, and this was the sort of structure that got chosen somewhere along the way. I can tell you where some things came from. I can't really tell you where everything came from. This is not one of them, I guess. So if I'm looking here, and I kind of sort of said it, if I want to do things first, I put them in parentheses. So I'm looking here, and I'll give you a hint. You're not going to get the same solution for both of these. They are going to be different. And you could probably guess like how they're going to be different. Probably by a factor of a negative. And so let's think about this. If this is in parentheses, I want to do the parentheses first. So I'm doing a -3. If I write out the definition of the square, I have this -3 in parentheses, and I have a -3 in parentheses twice. So this is another way you could sort of write this thing. And if I write it that way, I hope it becomes a little more obvious. Trying not to jump to it. But if I have two negatives, that's going to make a positive. And you could probably guess this is going to be the other one. It's going to be a -9, but let's not give it away just yet. So what this looks like is I do this thing first. So I'm doing the 3 squared first. So if I wanted to, I could maybe write parentheses around that 3 squared. And then it's kind of like I'm tacking on a negative. Or you could think of it, maybe it's like you got like a -1 multiplying by that. I don't know how you want to think about negatives. I tend to just drop this -1 personally and just think about the negative being there. But sometimes people need the 1 to kind of get them there. So 3 squared is going to give me 9. And then I'm going to throw that negative on afterwards. And so that's why this is going to give me that -9. And so this is one of those sorts of things, it's the notation that was sort of chosen, but it's important to kind of remember if it's in the parentheses, it gets the square treatment. So the negative is in the parentheses here, it's going to get the square treatment. If it gets the square treatment, 2 negatives is going to become a positive when you multiply them. Here, if it's not in the parentheses, it's not getting that square treatment. So it's like we have a 3 squared and then we're throwing on the negative afterwards. Okay, so now they're going to make it a little more difficult. Now we're going to go to fractions. And so if we're doing fractions, we're still doing PEMDAS. We look at parentheses, we look at exponents. There's none of those there. We look at multiplication and division. We got some multiplication there. And so we have this multiplication happening first. And so I want to do 1/2 times 5/3. And so now I'm going to ask, how do we multiply fractions? Do we remember how to multiply fractions? That should be the easy one. The adding and subtracting fractions is the one that is a little more difficult. So multiplying fractions, all we do is multiply the numerator by the numerator. So this is 2/3 minus, I want to multiply these two things. 5 times 1 is going to give me 5 in the numerator. 2 times 3 is going to give me 6 in the denominator. And now I've converted this to the problem 2/3 minus 5/6. And so now we're subtracting two fractions. And I've kind of hinted this is the harder one to add and subtract fractions. So how do we add and subtract fractions? Well, we got to get these denominators to match in order to do that. So we need to find a least common denominator, or it's the least common multiple of your denominators. So what we're looking for is the LCM of 3 and 6. And just so we're going in the right direction, multiples are going 3, 6, 9, 12. For 3, it's like 6, 12, 18 for 6. And I guess I should put a little ellipses to show that that's going on, right? And so we're looking for where those things first cross. If we have 3 and 6, it's not too difficult. They're crossing at the 6, right? That's the first multiple, that's the least of them. And so we need to convert these things to a denominator of 6. And so to convert denominators, we want to convert 2/3, we want to convert 5/6. And to review how to convert denominators, we're going to multiply it by something. We're going to get our common denominator on the bottom in the end. And so we're looking at this denominator. In order to get from 3 to 6, we have to multiply by the number of 2. And so if we multiply that by 2, we don't want to change this number. We want an equivalent fraction. So we're going to multiply it by a fancy 1, a 2/2 here. And so 3 times 2 will give me 6. 2 times 2 will give me 4. This one is a bit silly because 6 times 1 is going to give me 6. I don't actually change this one. 5/6 is still 5/6. And so we have 2/3 minus 5/6. And if I want to rewrite that, I can write that as 4/6 minus 5/6. And usually this is the step. If people mess up at this step, they'll look at this number and say, hey, that's not a proper fraction. I need to reduce that. Don't reduce that. You'll end up going back to where you just came from. Keep going with this. You have a common denominator. We wanted to get a common denominator. We want to do subtraction of fractions. So remembering how to do subtraction of fractions, we keep the common denominator, and we're going to do the 4 minus the 5 on top. And so this should be giving me a minus 1/6. And so to review a little bit about fractions and negatives, if we have a minus 1/6, that's the same as a 1 over like a minus 6. And that's the same if we put just like a negative out in front. So that will come up in the future probably. We'll probably talk about that a bit more. We'll probably definitely talk about something like that when we get to the concept of slopes. Okay, I think that might be the last one that we do that is order of operations. I think we start moving on to evaluating things. Then we're talking about evaluating things. And I said this a little earlier, we're not actually solving things. If we were solving things, this would have an equal sign. It would say equal some number, and we would solve for x. And our solution would look something like that. So that is what a solution would look like, but we're not actually solving things. What we're doing is they're giving us an expression. And so this is to express a mathematical sort of concept, a quantitative sort of idea, right? We want to talk about something. We want to talk about a number being squared and then subtracted by 5 times that number. So that's something we can talk about that is a quantitative property. It may not seem like the most interesting thing, I granted that, but it is an expression. It is a way to express something quantitative. So this would be an expression. The difference between an expression and an equation, which we'll get to later, is an equation has an equal sign with a sort of number or some sort of other expression over here. So it's two expressions being equal to each other would be an equation. This is just an expression. It doesn't have the equal sign. And so if we want to evaluate x squared minus 5x for x equals a minus 3, essentially what we're doing is we're taking this number, minus 3, and we're going to plug it in everywhere here that we see an x. And if you're evaluating something or plugging something in, anytime you're plugging something in, I highly, highly suggest you writing parentheses around the thing that you're plugging in. In this first one, I think you'll really see why it will help you out. Because if we put minus 3 and we put parentheses around the minus 3, and then we square it, that tells us that minus 3 is getting squared. If I didn't put parentheses around here, it would be like that other example I had earlier, and I would be off by a factor of a negative. And so minus 3 squared, and then I'm going to do minus 5 times a minus 3. And so I've kind of hinted at this, we did this earlier, but this negative gets squared, the 3 gets squared, so this is going to give us a positive 9. This has a 5 and a 3, so that's going to give us 15. The sign on it, I have a negative and a negative, so this sign should be overall positive. And I'm horrible at it. I should probably be writing equal signs all the way down. These are equivalent expressions. So 9 plus 15 is going to give me the number 24. And I guess I got just enough space to write it up there in my answer blank. Okay. I think I might have enough room to write this guy down right here. There's not a whole lot of room, but I think I got enough. Okay, so I have a minus x squared minus 3 times x. And the number I want to plug in is 2. And so this is a minus x squared. And so this is sort of like there's a minus hanging out outside. And so if I plug in x equals 2, I have to do the 2 squared, and then I'm tacking on the negative afterwards. And so that's what this expression means. And so it's kind of like they were trying to give you an example of both of them, one where the negative gets squared and one where the negative doesn't get squared. And so now we're doing minus 3 times x, which is 2. And I've said enough, but this is 2 squared, this is 4. And then we're going to tack the negative on. This is a minus 3 times 2, that's going to give me minus 6. And then if I calculate this, that should give me a minus 10. Now, example 6. So example 6, you probably notice differs from 4 and 5. So 4 and 5, we had a single variable. Now they're giving us 2 variables. They're giving us an x. They're giving us a y. It's the same sort of principle applies. So everywhere, everywhere that there's an x, I'm going to plug in a minus 4. So here's the minus 4. It's going to get plugged in here and here. Everywhere that there is a y, I'm going to plug in a minus 2. Okay, so let's write this thing out. I want a minus x squared, looks like minus, and then I do a minus 4 squared. So they're really trying to challenge you with your negative signs here, I think. And then we do minus 3. We plug in x, which is a minus 4. We plug in y now, which is a minus 2. And then we have plus y squared, which looks like plus, and I'm doing a minus 2, and I'm squaring it. Okay, so now we have to count some negatives. Here we're going to have a 4 squared, so the number here is going to be 16. If we think about this one, the minus or the negative is going to get squared, so this should make this positive, but then we still have this guy that needs to come down here. Another way to think about it is we have 2 negatives and then we have a third negative. So there's 3 negatives. That's an odd number of negatives. It's going to be negative overall. Same thing here. We have 3 times 4 times 2. If I do those numbers, 3 times 4 is going to give me 12. If I multiply 12 times 2, the number is going to be 24. And if I think about the negative sign, I have 1, 2, 3. That's an odd number. Overall, it should be negative. And the last thing is a minus 2 squared, and we're going to add that, so this should be a positive or plus 4. And I'm losing my equal signs there. These are equivalent expressions. So I did the exponents and multiplication. Now all I have is subtraction and some addition. So if I do minus 16 and a minus 24, that gives me a minus 40. And then I add 4, that's going to give me a minus 36. And we're almost there. So typically, if this was a face-to-face class, this would be something y'all would be doing in groups. And so really after the lesson, hopefully, or after seeing those few examples, you can start actually doing these on your own. Is the intent here. And so we have, looks like an order of operations with fractions. It looks like we have one with plugging and evaluating at different values, and it looks like we have another order of operations. Okay, so we want to do 5/4 minus 1/8 plus 5/6. So this is all addition, subtraction. So the first thing we actually have to do before we even go adding and subtracting these fractions is we have to find a least common denominator. So we need to find the LCM between the denominators, which is 4, 8, and 6. You could probably maybe figure a way to an LCM. And even if you don't get an LCM, even if you just get a common multiple, you're just going to have to do some more reducing in the end. This is about the only thing that's going to happen. And so it is possible to not get the LCM and still do it. It's just going to make the problem a little bit harder. You're going to have to do a little more reducing in the end. And so I think we kind of want maybe like a tried and true way to get the LCD or get the LCM of 3 numbers, or to get the LCD. And this might seem like a little bit of overkill at this point, because you might be able to find the number by yourself, granted. But this is going to come up later, and I think the sooner I kind of throw it out, the better off you probably are. And so what we want to do is we want to find the prime factors of these guys, of 4, of 8, and of 6. And so these aren't large numbers. This is 2 and 2. Of 8, it's 2 and 4, and then I can break the 4 down even more. And so I'm just keep on going to factors of these things until I get to prime factors, or the prime numbers. So this is nothing but 2s, this is nothing but 2s, this is 2s and 3s. And so this is their prime factorization. If I want to write it out, 4 is 2 times 2, 8 is 2 times 2 times 2, and 6 is, I'm going to write this out a little weird, I'm doing this for a reason. I spaced them out like this so I could look at these things. And so if I want to find the LCM of these three numbers, I have to look at the most amount of 2's here. So there's 2 2's here, there's 3 here, and there's 1 here. The most is 3 of these. So I need at least 3 2's. And that's one factor. Now I'm looking at this other factor kind of separately. And so I need 1 3 there as well. There are 0 3's here and there are 0 3's here is another way you could look at it. It's kind of silly, but there are no 3's here, right? And so the largest number of 3's is 1. Out of 0 and 1, 1 is the largest. Okay. And so you may not want this number in like its prime form. So we want to figure out what this is. 2 times 2 times 2 is 8 times 3. I believe our LCM is going to be 24. Just as a quick recap, we get the prime factors. We write out the prime factors and we kind of order them in a pretty sort of way. We take out the most of any one factor. So the most number of 2's was 3 2's. The most number of 3's was 1 3. We multiply those all together. This is going to be our LCM or our LCD. It's the least common multiple of the denominators or the least common denominator. Okay, so that was a lot of work to get one number, but we did it. And it's going to prove itself useful. So 24 is the magic number that we're looking at. So going back, we have this 5/4 minus 1/8 plus 5/6. We want to convert each of these things, 5/4, 1/8, and 5/6. And now we're converting fractions. And so we want the denominator to be 24. And so we're looking at these three things. The first thing I see, I want to go from 4 to 24. What do we multiply by 6 to get there? What do we multiply by 4 to get to 24? Would be 6. Sorry. We multiply by 6. We do it on the bottom. We do it on the top. 6 by 4 gives me 24. 5 by 6 gives me 30. I got to multiply 8 by 3 to get to 24. I do it on bottom, do it on top. Do 3 times 1 is going to give me 3. Do 6 by 4. 5 by 4 will give me 20. So these are the fractions converted to common denominators. Now, we've done most of the sort of legwork of getting this thing set up. Show this thing on here. Okay. Believe I can show them both at the same time. So we want to start off with a 30/24. We want to subtract 3/24. And then we want to add 20/24. And so we've gone over this already, but we combine everything over that common denominator. And so what we're actually doing is 30 minus 3 plus 20. 30 minus 3 is going to give me what? 27. And then I add another 20. I believe this is going to give me 47 over 24. Okay. And that seems to match up with what I have in my key that I made earlier. So that seems good. Next thing is an evaluation problem. And so I want to plug these things in. So -1 is going into this X spot. It's going into this X spot. And here's my red pen. minus 2 is going into the y spot. Oh no, that one didn't want to work. Minus 2 is going into the y spot. There we go. And so this looks like, if we write this all out, minus 1 being squared plus 2 times x, which is a minus 1, times y, which is a minus 2, minus 3 times y squared, which is a minus 2, being squared. And now we're going to have to count a lot of negatives. Well, if 3 is a lot, I guess 3 is not too many. So if we count these, this is a minus 1. We square the minus 1, and then we tack on a negative. So this is the 3 negative thing we saw earlier. This is plus 2 times 1 is going to give me 2, times 2 is going to give me 4. So the number here is 4. If I count the negatives, I have 1, 2 negatives. So this should be positive 4. I think I'm going to do this one in steps. This is minus 3 times a minus 2 squared. So the minus 2 squared should happen first. Minus 2 squared is going to give me 4. And so let me rewrite this out. This is a minus 1 plus 4. And now if we look at this, this is a minus 3 and multiplying a 4. This should give me minus 12. And now I'm going left to right, adding, subtracting. 4 minus 1 should give me 3 minus 12. 3 minus 12. So hopefully you notice the negative is larger, so this number should end up being negative. 12 minus 3 gives me, what, 9? And we're talking about the negative 9. Okay. We're getting there, almost to the last one of our first lesson. Okay. So the last one is some simplifying, some more order of operations. So if we're looking here, I'm looking at the top, looking at the bottom. I'm looking at the top. The first thing I'm going to do is parentheses. The first thing I'm going to do is that thing that's in parentheses up there. So I got, I'll do it step by step. 2 times 3 minus 3. First thing I'm going to do is this parentheses. 9 minus 6 is going to give me 3. And I'm looking at the bottom. I want to do parentheses exponents. Ain't got none of those. But the first thing I do have is multiplication. I can do some multiplication. So if I do 4 times 2, that's going to give me an 8. If I do 2 times 8, that's going to give me 16. And I have to subtract these two things. Okay. And now I'm looking left to right. I can do 2 times 3 is going to give me 6. Minus, what, 3 times 3 is going to give me 9. And I still have 8 minus 16 on bottom. I guess I could have done that, but now I'm going to do them both at the same time. 6 minus 9 is going to give me what? Minus 3. 8 minus 16 is going to give me a minus 8. And if you wrote this, I would probably give you most of the credit, if not everything. But I would wince a little bit. Anytime you have a negative over a negative, that's 2 negatives. This is really the same thing as a positive 3/8. And typically, we're going to write it as the positive 3/8. Okay. And that should conclude the first lesson that we're going through. Thank you for standing by.